Hello. I think I'm the first one here. There's not actually, there's 0 viewers. This is Tuesday at 2 o'clock in the afternoon, Midwest time. So, hey, we got Old Salty. So we have 2 viewers and Kill Creations. We gotta go. Oh, look at everyone just joining in. 10 people just jumped in. It went from 0 to 10. So I got a fancy box in front of me with these LDO stickers on it. If you haven't heard or seen, I got some fancy T8x2 lead screws for my Mark III to replace these T8x8s, which are standard on the Mark III. Even came with the palm nuts, so that way I don't have to print any palm nuts or make any. But we have a 35. Man, we went from 0 to 35 in like a minute. Hey, what's up, everybody? I did get some other cool stuff. These are Peak. So this is a little bit different than Palm. This is Peak, so it's a little bit more durable material, and they're also tighter. So this Mark III back here is testing these tighter and more fancier materialed lead screw nuts. I also got some, these are super fancy, some of these spring-loaded palm nuts for anti-backlash. So that'll be another test here in the future. So it's been a good shopping day. Hey, what's up, everybody? Keep getting more humans. There's Will and Pedro and David just joined in, and backlap. I have no idea what a backlap is. Is that a backstroke lap? I have no idea. So yeah, I got a set of these, so I'm not just going to put one T8 on one side and one 2 on the other. So there's my pair. There's a cool step motor in here that I needed. So, hey, it's Matthew Seabrook. So let me hide this LDO box. There's other goodies in here. I'll put these other goodies back in. We don't need to talk about those fancy new palm nuts that are made out of Peak instead of palm. Excuse that I'm back at my other microphone. I took all my wireless microphone stuff to the studio so I can record tutorial videos. But then I came back here and I'm like, I'm gonna do this live video, and I've been busy all weekend with projects for one of my largest corporate accounts that hires me to do photography and creative counseling on stuff. So from Saturday until yesterday, I was working with them. So I didn't go to the studio, but these are crazy. So why are we doing this? Probably everyone's just like, why are we switching to these really fine Z screws? I have no idea. I follow the Railcore 2 printer, and they have an interesting printer. I think it's one of the coolest printers on the market, more so than even a Prusa Mark III. It runs Duet 2 and is tool changer capable, which E3D just announced that the tool changer will be $1,500, which is totally fair, right? That's really expensive. That's as much as a Railcore, which costs $1,500. Hey, what's up, Canada? Someone has a question. What's your question, Matthew? But basically the Railcore runs on 3 T8x2, which means that every full rotation is 2 millimeters versus the stock Prusa, which a full rotation moves at 8 millimeters. They run it on 3, and they do a manual bed leveling. So the 3 axes actually shift to level the bed, and then it moves up and down, which makes the bed extremely flat because they're using an aluminum, a Mix 6 aluminum bed. So it's extremely flat. It's the flattest, and it will not warp, and it's kind of amazing. But they're able to get layer heights of ridiculous accuracy because they're running these T8x2 lead screws, and the quality on the printer is really good. And I'm like, man, why not try that on a Prusa? So talked to Jason from LDO, custom ordered these bad boys. They shipped before Chinese New Year, so I actually got these things much earlier than he said. He said it'll probably take till Chinese New Year. So hey, what's up? Someone from the Chuck. Yes, Railcore will be at Murph. They've already announced that they will be there, and I think they're a sponsor, so they'll have a table. If you are going to be at Murph, I will be at Murph. I'll be at the Bondtech table, so they offered to seat me at their They got a gold table, so I'll be sitting there, and I'll bring this. This will be there, my full bare Bondtech extrudered Mark III. So I do have to change the firmware. Well, I don't have to actually change firmware. I just need to change, which I'm going to show you guys. I need to change the E-steps. So this is 4 times the resolution on the Z-axis. So I need to go in and change the Z-steps from whatever they are to 4 times whatever it is. I don't recall what they are because I've never actually had to change Z-steps. So I'm glad you enjoy the pretty PLA profiles. There'll probably be some new ones for no, just there probably won't be any new ones for a while. They're pretty solid until something new happens. But yeah, I do need to change the E-steps, which I'll show you how to do. I've got this thing hooked up to my Repetier server back there, so I can quickly show you on the screen the changing of the E-steps, which will just be an M92 command. So super simple. And then I got to save it with the M500. Other than that, that's all you need to do to make this work besides having these things and installing them. I'm not going to change anything else. This should be pretty quick because I am running the full bare, so I just need to pop off some screws at the front Z's, pop the tops off, and then the whole gantry and Z-axis motors will be what am I printing back here? That's actually a good question. So I mentioned that I just received some Peak trapezoidal nuts. So these things are palm, and one thing that's nice about this T/2 is there's no wobble. Like, these things are solid. On the T8x8, there's a little bit of wobble, and I asked Jason from LDO if he can send me some tighter ones. And the only issue with going tighter with palm is actually a pretty weak material. It wears down pretty quickly. So if you go too tight, it's just going to loosen up over time anyway, because it's a less resilient material. So he sent me them in Peak. So I installed those Peak palm nuts there. So I'm running a test cube to see if there's a difference between one or the other. And I don't think there's going to be a big difference. It just, you never know. I like asking questions and trying to figure out if I can solve them by getting the product and fixing it. So this isn't solving a problem. The Prusa doesn't have a Z-axis problem, but theoretically, this can print a layer height of 0.01 millimeters or smaller, because, you know, I think the smallest step on here is pretty crazy, but I don't have a price. I think he billed me, and I just have like a billings account with LDO, and they sent me a bill, and then I just pay the bill. So I never looked. So I do not know what the price of these will be. I'm guessing somewhere in the $80 range each, maybe less. I don't know. Jason was talking about it on the Prusa Discord, the Wasteland 602 Wasteland Discord. So I don't remember. He said something about a price, and he just had like a guesstimate, because again, his price is a direct. He doesn't sell direct to clients. I just have an account with him as if I were a distributor, but I do not distribute. But if he's going to sell them to the public, there's also an increase to the price. So you have to weigh in what a store would sell them for. So well, Phil, I probably won't print at 0.01, but 0.02 is actually a layer height that many of the Railcore users are using. You do have to have some crazy settings, and definitely you need the Bondtech extruder so that we have a nice, even and smooth distribution of filament. That way the pressure doesn't back up too much, because that's just going to make it pretty nasty. So independently wealthy, no, I'm just insane. I do own my own. I own technically 3 businesses, and it helps me buy things for printers. But if I was independently wealthy, there'd be way more printers back here. So I've stopped buying printers. I just buy, like, you know, this and go, will this work? So we're just gonna swap these. It should be pretty simple. Hopefully, it shouldn't require any major surgery. I do need. Did I forget one? I need a 3mm. Do I have a 3mm thingamajigger? Nope. I need to roll back. I'm back. Yeah, I actually am hiding one printer. There's one printer on the ground here that I've been meaning to live stream build, which is that Anycubic Linear Plus 2. So yeah, there is one printer hiding, but I did get rid of my other one. So I sold my CR10, sold my Mini Delta, sold my Maker Select. No, Matt, I haven't gotten a Nozzle X, but I just literally 30 minutes before I went live, I got the email from Philistruder that they shipped my Nozzle X. So the Nozzle X will be here sooner than later. So I'm excited for that. So since this is a bear, there's a couple things that need to come apart that are a little easier. But before I start taking it apart, I'm gonna send the G code over. So let me screen share here. Where's that screen share button? All right, screen share. Share. Oh yeah. All right, so we're in our Repetier server, and commands turned back on, and as you see, the camera's definitely, yeah, the camera's weird. So we're gonna send a G code, and let me send an M503 just to see what the settings are first. And M92, the Z's are 400, so that'll put the Z at 1200. I might need to write a new. I might need to send a new firmware because a Z at 1600 is going to be pretty insane. It probably doesn't need to be 1/16 micro stepping. I could probably go down to 1/8, and that would just double it to 800, which would be much safer. For all intents and purposes, to ease this through, I will try the Z1600 and pray I don't blow anything up. So M92 E1600. Nope, not E. I'm so used to sending E. Z1600. Sent M500 and M503. Make sure it's stuck. Yep, there it is. There's our Z1600. So our resolution is going to be insane. There might be issues of desync. There might be issues that it can't handle that many micro steps on the Z. I might need more current on the Z. I might need less current because there isn't as much of an angle of attack on these. So should be able to hold gravity better. So we'll find out. So that is all you needed to do to make these work G-code wise. I will find out once we do this. I'll slice something and try to print it with these crazy settings and see if I can handle some step set. I mean, it's not going fast. The Z-axis doesn't go. It's like 16 millimeters per second or something. It's not a very fast movement. So yeah, we need more power. I definitely need to throw like a duet on here and just not work with the Prusa firmware. Let's see here. I don't think it'd be dangerous as much as it might desync because it's sending a lot of pulses to the Z-axis. So the gantry might not be able to handle all those steps. So it might skip a step, but it might not skip a step uniformly. So it might, start getting cattywampus while you print. Yeah, and then you'll start getting pauses. So that's one of the downfalls of the way the Prusa designed their boards. They run one stepper to both Z-axis, so they're actually they're synced together via one stepper. The more powerful boards will have a stepper per each, which would then there's benefits, I guess. I haven't really thought about it, but we got what we got. And Senator Crispatine, we definitely need more power in the Prusa land, which I feel 2019 will be the year that we finally see not a 8-bit board in the Prusa land, at least the original Prusa land. I'm guessing, you could throw anything you want on here. If you saw Chris Riley's video on that Marlin 32 board, he threw that on his log. So the wooden Prusa he made. So why not throw it on a real Prusa? And then you can have S-curve acceleration and fade on your Z-axis, my thingy, mesh bed leveling, and all that fun stuff. Yeah, I need to also try Clipper. I mean, if this is too much, I might have to throw Clipper on this, which isn't that bad. The only downfall is I wouldn't be able to run this on my Repetier server because Clipper runs on a Pi, which needs to be connected to here, and I can't run Clipper on my Repetier as far as I know of. Maybe you can, but I feel it needs the Octoprint installation to run. So let's get ahead and start disassembling. Now, there's a little bit of difference here disassembling. There's two top covers that top the V-slot extrusion, so I need to pop those off, which is 2 screws. And then I can remove the Z-axis toppers, and then I can remove the 2 front screws. I guess I should point to these. There's the 2 front screws in the motors, which then will slide off. So simple surgery here. Once we get that apart, I should be able to remove the Z-steppers pretty easily. I'm going to throw some nitrile gloves on because I heavily greased not only the threaded rods, or the smooth rods, but there is some grease on the threaded rods. I've just always put a little dab of silicone grease, the stuff you're not supposed to use in the bearings. I just put it underneath there, so that way there's a nice smooth motion. So let me throw those on because I don't want to get nasty while doing this. And I excuse my tiredness while I'm on camera today. It's been busy. I didn't fall asleep at all Sunday to Monday. I had not an ounce of sleep, and then I had to work all day. So, hey, what's up, Steven? Oh, son of a gun. So, Trevor, you're gonna have to help me out, man. I need to figure out how to run the Clipper with my Repetier because that would be awesome. Oh, now it look cool. But yeah, I didn't sleep at all, and I had to shoot all day yesterday, and then hang out with everyone afterwards. And I think I slept today. Steven, we are swapping these standard T8x8 threaded rods for T8x2 threaded rods. And I don't know if I can get close enough to really show they probably won't focus because it's just so thin. But they're much finer. So it's 4 times the resolution. They're also much flatter. So usually the angle on a T8x8 is about, say so there. These are like, meh. So the gravity is going to be in our favor. These are also should be less backlash overall because there's just less wiggle wobble. I mean, these palm nuts, they don't move. They do move slightly on the T8x8s, which is your more standard threaded rod. So let's pop off these caps. And again, I don't have my fancy microphone because they're all at the studio. Because I was doing some recording of some videos. And I don't even have a thing. I don't even have a container. I'll use this 40mm cube that has no top on it as my container for parts. Hey, what's up, Gusner? You know, I'm not sure if they can handle the 1600 or 1600 steps on the Z. We're going to find out. And if that does need it to, I do have a screen over that I can go to, and I can bust out a firmware real fast. And once I bust out that firmware, I can test it there. So the nice thing about the T slot or the V slots is I'm just going to unscrew these things slightly. Not actually pop the screws completely out. Get in there. And that'll stay together. Same over here. And 3D Gusner, where did I get them? I got them directly from LDO. So, but if this does work out and people want to get them, David from Printed Solid said he'd carry them. It's no issue for LDO to make these in quantity. So if this does work and proves to do something, oh, Oh, well, Gerald, thank you. I didn't. All I remember is that it's for some reason I always felt it needed to have Octoprint, but I'm glad it doesn't need to because I would like to. Yeah, I'd really like to play with Clipper. I need to hit up Josh from the Prusa group. He's one of the admins there, and he has the Clippers and he loves it. Yeah, I wish Prusa would too, but I mean, with Clipper, you get basically Prusa, but you still get the awesome 32-bit math and some other fun things. So, well, with a 1.8 degree and 16T, I believe it is 0.01 millimeters per step with these, I believe. If you went to the 20T and 0.9, I think that would be the better match. I have run a printer with all 0.9 degrees and it ran fine. It just didn't, there was zero print quality increase because we have a 0.04 millimeter nozzle. So getting more resolution on the X and Y, you're not really going to see it. You will definitely see if you go to like a 0.02 millimeter layer height versus 0.05, you will see the fact that there's absolutely no layer lines. But yeah. Hey, Chris Riley. We got Chris Riley. We have the two Chris's in basements in here. What's up, Ragnar? Yeah, there wasn't, I couldn't tell. Like if you're, I printed, I normally print like, fun things like this. This is my little tool holder out of Filamentum Gold Happens and whatever. I was not able to tell a difference between 0.09 and 1.8 with just the eyeball. I'm guessing if I got a scope or, something really needed to be even more accurate, I guess you might see something, but you're measuring most things with printers in millimeters or, tenths of millimeters. You're not really measuring it. Steven, should you? Only if you want to. I do notice a little bit better print quality with the LDO 0.9, but it's another like, is it so much better that you need to spend $20 more? Not really. Yeah, Michael, the extrusion looks completely different with the Bondtech 3-to-1 versus stock. You definitely lose that basket weaving pattern, which was always the plague of the Mark III. Like I have a completely stock Mark III back here, not printing anything, and it still has that slight basket weaving. I've been able to tone it out with good alignment and everything, but it never goes completely away. It does come with a 1 point. It's a Motec 0.8 amp. 0.8, yeah, 0.8 amp, 1.8 degree slimline stepper. How am I remembering these things when I'm like half asleep? The only other settings I did were print settings. So I typically like to print at a 20 millimeter per second perimeter speed. The issue at 20 is it seems that multiples of 30 cause resonation on the Prusa. So 30 millimeters per second is like a treble speed. So when you run at 20 and you multiply that by 3, that's just 60. So it's actually running at 60 millimeters per second to put out 30 or to put out 20 on the thing. So you kind of have to work around your setting. So actually go to like 25, which is weird. But yeah, the differences are mostly that lack of basket weaving. I mean, you'll still have some inconsistent extrusion because there's always going to be some inconsistencies. It's just the way that the extrusion looks is different. At least that's the way I've kind of noticed it. Oh, that's way too fast. Okay. let's swap out these front 2 screws. Yeah, it's kind of weird how the overhangs, even for me, my overhangs got better. I don't know if it's just the better extrusion when it's doing the bridging, but Mark, I'm running a custom firmware I made for my Bondtech because I am running a 0.9 degree, and I saw no difference between running it at 1660 or 830. So I'm running it at 1/16th micro stepping at 830, and there is absolutely zero quality difference, but you're taxing the processor less. So anything to make sure you're not taxing anything or getting stalls, because I tested it, and at 1660 I was able to print a normal like object at 120 millimeters per second, but I like to play safe sometimes as much as I play crazy a lot of the times. So all right, 2 more screws and we can pop this whole gantry off. You know, I can definitely test it. I have a GitHub with all of the everything I've done and what command lines I change it on. So if anyone wants to go back and try everything, but I've never tried quarter. You would definitely see. I don't think you'd actually physically see any difference. I don't get any mowear with this setup. My prints are completely mowear free. So actually, to get to the hot end, it's 3 screws. If you remove, so there's these long screws that reach all the way from the back to the extruder motor. You remove 3 screws and the whole front comes off. I mean, you still have to take off 2 screws in there, and you still should take off the front fan, but it's only 3 screws and the whole front of this comes completely off. You don't have to disassemble the whole thing. Go hit up Filament Frenzy on Twitter. He posted about it, and he's like, oh my gosh, it's only 3 screws. And I take it, but yeah, it is. It's just 3 screws from the back, and this whole thing pops off the front. I think of the Bear, there's 1 extra screw. Yes, the stock ANSI board. It's basically stock. Yeah, minus the fact that there's a sturdier frame that doesn't, I mean, my table wobbles. I can't actually get the frame to wobble. So I need to depower. I need to power this down. And we're going to raise this all the way up to the top without bending anything. I'm just manually threading this rod up. Okay. And come here, smooth rod. And pop these front caps off. And come here, motors. Oh yeah, I still need to unscrew the other 2 motors, or 2 screws from the back. I'm a silly panda bear. Correct, Will. Hey, Poland, that's where that's where my family is from. M-O-I-R-E. So actually, I've got a print that shows it off great. Let's see if this will show up if I put it in the light. Just come on. Come on. Yeah, maybe not. I can get it to focus, but it's hard to get the light just on it. There's like a zebra pattern. I have a better picture of it somewhere on the internet. Yeah, it's too hard to see because that filament hides things. But it's just a diagonal pattern that forms. And depending on the motor you have, better or better. But yeah. It was something that plagued the Mark III. And other printers have it, just not to the degree. A lot of it was just that motor tuning, and they added linearity correction to help alleviate those wear patterns. Yeah. Excuse me. I actually have a photo of it on the forums or on the Facebook group. It just shows how bad it was because I actually tried to get it. So one of the things with fixing issues is if you can make it worse and you only changed one thing, you know that if you do that thing the opposite direction, it should get better. At least it should. Sometimes it doesn't always work. Sometimes it gets worse both ways. And then you're just yelling at yourself because you're like, how does that make sense? Good evening, Martin. All right. We can now slide the whole gantry forward. And then I can remove these fancy smooth rods. And then I can remove the Z-axis rods with a little twisty motion. Let's see. I wouldn't actually. Why would I do? I don't. 0.0125 isn't a number it can. I mean, I guess it could, because micro stepping. But a full step is 0.01 millimeters. So you might as well use the full steps and not use micro stepping as much. I mean, you won't actually know if you're in a mid, but it just magic. So now I just need to disconnect the motors from the board and put the new motors to the board and then viola. So a Prusa uses a T8 by 8. And at 200, so if you got, so it moves 8 millimeters in 200 and in a 1.8 degrees, 200 steps. So it's 0.04 millimeters per step. And then it's 2 millimeters in the Z with 1.8 degree, which is 200 steps. So 200 or 2 divided by 200 is 0.01 millimeters. Yeah, the Prusa doesn't do 0.05. The Prusa is 0.04. It does 8 millimeters in 200 steps. So 8 divided by 200, whatever that is. At least that's how the math should work. Because it's the Z-axis change in one rotation. One rotation is 8 millimeters on a T8 by 8. And this is 2 millimeters in a full rotation. So 200 steps. So 2 millimeters divided by 200. So at least that's how the math should work. If someone correct me if I'm wrong. I've never used an enclosure. That's actually on my list of things I've always wanted to buy or build. I looked at Masumi makes amazing extrusions. So I was like, oh man, I can make this cool thing out of extrusions. And then I priced it out. I'm like, man, I can buy another printer for for this. So I never went through with it. But it might be a project I do. Might be another project that I do later on in the future where I'm like, I'm going to build this fancy thing because I've got a couple places that can cut custom extrusion. And if I kind of open source it, then I can be like, printed solid, carry these things, and everyone can build it. Chris Riley backed me up on the math, so it is 0.04 millimeters per step, full step. I mean, you can still consider micro stepping to help you out there. All right, let's see here. I need to actually stand up. Haha. You know, I really actually did like my CR10. It printed really well. There was no issues with it. I'm just, I got I'm kind of lazy. So, you know, not having that Z probe and messing with that just kind of got annoying. As much as I love the fact that it had a glass bed and it was super flat, still having to manually level the bed kind of like made me, I don't know. I just felt like whenever I turned the Prusa on and wanted to print, it would print. Sometimes the CR10 was like, I just need a little bit of touching and tweaking and I'll print perfectly. You know, because eventually the manual bed leveling would need to be adjusted slightly or whatever. I didn't really spend enough time with that, but I think the CR10 is great. I'm going to order a CR10S Pro probably this summer. It probably might drop in price, probably find it cheaper. I'm definitely not a get it first guy as much as I want to be. I got this gantry just hiding out here. I need to clip some wires. Well, not the wires. I need to clip some zip ties. Let's see what I can do here. All right. I was able to clip the zip ties without damaging anything. So here's one. I don't know if this will show up on camera, but then you can kind of see the difference in angle if it does want to focus. Let me see if it'll focus if I move my head. So yeah, you can see it there. That's the angle difference. Okay. All right. So we got a shorty wire and a longy wire. And he sent me two with the same length wire. Perfect. This will go here. Oh, I guess I got to replace these palm nuts first. This is going to take a while. Oh, spin. A lack room. Actually, the humidity in here is a little high and the temperature is way too cold. Official 7x7. Who knows? The community has continued working on the 7x7 firmware, and they've polished it more. And I think they even added it to the Zero Beast firmware. They've, yeah, it's kind of fabulous. Yeah, this is a good finger thumb workout right here. I'm still going because you can't make it fall either because the step angle isn't high enough. So it just spins. Yeah. See if the height is right. It looks a little lower. Yeah, it's just a touch lower. I'll yell at Jason later. Yeah. You know, actually, I do have big hands. My buddy's 6'8", and we have the same size hands. So, and the only reason, it's funny, this actually came up in conversation yesterday, and they're like, "How did you find this out?" And we played basketball one time, and I could palm the basketball, and he can't. And he's like, "How can I not palm the basketball?" So, yep, if I try really hard, I can palm a basketball. Can't dunk though, because I can't jump over like 6 inches in height. So. Okay, we're almost at the end of this palm nut coming off of this. Should have done this before I started. You can spend 30 minutes watching me unscrew a palm nut. Okay, that will go there. These I'm going to just take off the table so I don't break them. And then the next one. Oh, you got the full upgrade from the Mark IIs to the Mark III. You know, I actually had one on back order. I ordered it, and it took so long for them because they shipped, you know, regular Mark IIIs forever. I canceled it, and I don't remember what I got. I think I got a CR10 or something. I think that's what I did. I just couldn't wait for my Mark IIs to Mark III upgrade. Yeah, the bear upgrade is awesome. This frame and the way the parts are done, like to do this on a Prusa right now, I would have had to take way more apart to take these Z-axis motors off. If you ever ask me about the Railcore 2 as I break things, my answer is always going to be, it's awesome. The Railcore, the guys who work on it, Tony and all them, the community that they have on the Facebook group is fantastic. Toby, most printers run T8 by 8. So the only reason it's an upgrade is 1, more precision, 2, better with gravity, 3, yeah, and it's an exact full steps are exactly 0.01 millimeters. So less rounding error. Actually, it would be literally impossible to have a rounding error unless you, yeah, unless you put a layer height that was less than 1/100th of a millimeter, then you might have some rounding error. But yeah, it's mostly the rounding error. I thought it'd be kind of cool to try out. So, oh yeah, it's still cold. The basement is 17C. Yeah, it's kind of fabulous. See, is my print done back there? Almost. I'll be able to find out if those peak palm nuts or those peak trapezoidal nuts do anything. Trade these out. Yeah, it's not the grooves, it's how much a full rotation moves it in the Z-axis. So a T8 by 8 is an 8 millimeter in diameter threaded rod that on a full 360 rotation moves it 8 millimeters in Z-axis height. So that's how that math magic works. Okay, we don't want this palm nut. Can't confuse this with anything. Ow. We'll put this one in. Yeah, I was also confused on what T8 by 2 and T8 by 8. So if I sound like I know what I'm talking about, it's only because I researched this recently for this. So yeah, but T8 by 8 is what's probably the most common that you'll find on 3D printers. Getting a T8 by 2 is extremely uncommon. T8 by 4 is definitely a good upgrade because it's kind of the best of both worlds. You're not using too many steps, and you're also not you're still getting a better resolution. So yeah, it still has the 4 grooves in the palm nut, but the palm nut could be any size. Don't look into this until I actually test it, because I don't even know if this will run. This is, I mean, it'll probably run. I don't know if it's going to do anything. One of the cool things is I really want to see if I can print some really, really high-end minis with this, even though I do have a resin printer back there, got the Photon. I just want to see if I can print at 0.01 millimeters. Yeah, the Nylock method for bed leveling is kind of amazing. And then once it's set, it's set. The only downfall is the bed still warps because it is the PCB. So it can warp in between the Nylock nuts, but it's still better than not. Math magicians do poofs. Oh, math magicians. All right, my other print finished. I'm going to put this over here so I don't actually put that on, because that would be horrible. Correct. That is why that magic number comes up so often, because T8 by 8 only moves in full steps. I mean, yes, you're micro-stepping. But believe me that with gravity and all that nonsense, you're not getting those Z steps to stay at ridiculous micro steps. So just throwing that out there. I hate breaking the bubble or bursting people's bubbles, but microstepping is great on X and Y, but when gravity has to hold it there and all this other nonsense is going on, I don't think it has the holding torque to hold. Give us the cube. I'll bring it over here once I put the Z back on. All right. Ugh. So many rotations. So many rotations. This is a bear, not a Zerbo. Kind of the same thing, just different. Both amazingly awesome. Okay, just a little bit more. Oh, 4 times the resolution. I'm getting a forearm workout now. My fingers got to work. This is a good workout day. This can go here. And I can insert this bad boy. I'm tired already. Will they have a better chance of binding? Yes, theoretically. Oh yeah, Zerbo's definitely a trustworthy place to buy. Wolfgang, the guy who runs Zerbo, good guy. Zerbo makes awesome things. He's always part of the community, so I would definitely say yes. Trustworthy fellow and trustworthy place. I'm just not in Germany, or I would order from them. I'll loosen this up. I'm going to attach this the other way. My fingers are greasy. Yeah, I could just put the power to them. But you know, I'm weird. All right. Yeah, definitely the modern printer. But we have to remember that micro stepping is an issue, and the magic number is more or less about the rounding error. So if your stepper moves at 0.04 millimeters per full step, and you try to go to use a 2.5 millimeter 0.25 millimeter layer height, there's a rounding error every single layer that you move. So, and trying to stop on weird areas is just weird. So yes and no. I don't think that microsteppling definitely helps, but I don't think it's as helpful on the Z-axis as it sounds. Okay. And level the gantry a little bit. Slide these bad boys. Come on, wire. Boom. Oh, that's better. Okay, let's go grab that cube. I'm going to take my gloves off. Go grab a cube. Let's take a look at it. These are not for recycling. Those are nitrile. He's so pretty. It's a pretty cube. Ooh. Yeah, and backlap, that goes back to the other mentioning that microstepping. They don't feel like the magic numbers do anything. I haven't physically seen the magic numbers do anything, but I have seen results that it did do something. So it's just like, you know, I've printed at different layer heights and I don't see a difference, but this cube, get under the harsh light there. Not bad. Did it do anything different? I'll let you know once I get another cube. I have one that I printed earlier, but it's upstairs. Smooth. Okay. Now, Milan, is it precisely 0.01 millimeters? You got to remember the holding torque is weak in between steps. So you lose the ability to hold weight accurately when you're using microstepping on the z-axis. Unlike the x and y, there's no weight to hold once it's stopped. So microstepping is much better on the x and y axis and much more accurate. On the z-axis, on the other hand, trying to sit there and hold it at a quarter of a microstep up, you know, a quarter of a step up, you're not getting a full hold on the actual weight of the gantry. You can up the current to try to do that, but it's still not perfect. But that's what we're going to find out. I didn't use Simplify 3D. I actually used Slicer Prusa Edition Alpha 3 to print the Joker with the support. Yeah, and that's the debate. I don't believe either camp is 100% correct. I don't believe that microstepping solves everything, and I also don't believe that magic number solves everything. I do believe better technology can help. Getting a stepper that's more accurate and needs less microstepping is definitely better than one that needs more microstepping, because again, there are issues with microstepping. Now on the Prusa, we are interpolating all the microsteps with the TMC driver, so it still is positional at 1/16th microstep, but it's all being converted to 256 microsteps. You don't actually get 256 microsteps because the positional is still, it just changed the PWM, the pulse width, to being a perfect synodial curve. But, you know, there's math magic. Hey, Mark, how's Germany? Mark, you're in Germany, right? I'm really bad with that stuff. Yeah, and I think a lot of that magic number stuff on the Mark III doesn't work because of that 256 microstepping. And is the Ender just a single Z screw, or does it have two Z screws? I can never remember. I know the CR10 is a single Z screw. So I think it helps definitely there, because trying to hold the whole axis with one Z stepper and it just seems like, yeah, it just seems like an odd way of doing it. So I think the magic numbers helps there more. But yeah, on the Prusas, I've never really noticed the magic number help or hurt. But at least this thing, there's no way, you don't need a magic number. So it's just 0.01 on a full step. So whatever layer height you want, as long as it's an increment of 1/100th of a millimeter, you should be able to attain it without having to use any micro stepping. So, but then there's the other camp where, again, they're right. You don't always start on a full step. But there is a camp that says when you're printing with the Z-axis, eventually it's going to fall into a step. And once it falls into that full step, it's going to move into that step all the time. So, yeah. We'll find out. And that's why I don't really recommend this mod. Again, well, I don't recommend it because I haven't tried it, but I don't recommend it just because it might not do anything, and it's a pricey upgrade. And for most Prusa Mark IIIs, this is actually quite an intensive surgery. On the Bear, it's, you know, a few screws and you can pop your whole Z-axis off. And as you saw, it was pretty easy. Like, you know, Tom, I will buy some spray paint and I'll send you some threaded rods that are black. Will they last? I don't think they will, but you know what? You can test it and tell me. I did see someone with carbon fiber X and Y axis rods, so that was pretty sweet. Yeah, we'll find out. I mean, you know, at least this way, because again, the only test that I have is looking at people who print with the Railcore, and the Railcore prints great at 0.02 millimeters. I've seen other people print at 0.02 on their Prusa, and it prints, but it doesn't print that great. So in my mind, that tells me that the microstepping isn't as accurate on the Z-axis. So the logic tells me that the camp that says microstepping isn't the way to go on the Z is probably a little bit correct. But then again, not very many people of us want to print at 0.02 millimeters because that's going to take forever. You might as well get a photon for $500 and, you know, print resin prints. So yeah, you know, and they liked him. So he's on Twitter and I know him. And, but one of the things I'm horrible with is names. Native 256. Come on, Mark. I don't have the TMC 5130s. Isn't that the new one that they're putting on the, what are they putting on the new Duet 3? That's what I'm waiting for. I'm waiting for the Duet 3, and I can't remember what fancy steppers are putting on there. Dun dun dun. Yeah, I put grease, especially on the smooth rods and everything. And every time I do this, I get covered in grease. So I'm not doing that this time. I'm done getting covered in grease for the YouTube world. Ooh. The German 3D printing nerd is putting the regular American printing nerd under the non-nerdiness because that's super nerdy. And that sounds awesome, by the way. I wouldn't mind trying out native 256, but that's just me. All right, we're almost ready to just see if the Z-axis moves. Okay. Good. I'm going to put the front little platies on. Where did I put those? They slid off somewhere. Yeah, it'd be funny if this was a fix for anything. Man, Aaron, you're going to have as many Mark IIIs as I have, which is 3. And I still have one that's basically completely stock. So the good news is I'll have a nice break on Thursday. Thursday's the first Thursday of the month, so it's the we have a drink and draw, which is there's a bar that hosts artists, and the artists can bring and draw and paint and whatever. And I bring my 3D printer and I live 3D print and I show off prints. So I'll basically have my wall of veteran things. So it'll be my nice rest day. I'm gonna go eat a yummy sandwich and show off prints. And I have to figure out what print I want to print. Okay. I'm only going to put 2 screws in there. I am going to put the Z toppers back in. Let me bring the those down. Okay. Z toppers, which I might have to stand up for because I left the T-nuts in them. Huh. You know, I've never actually priced that. It'd be kind of interesting to find out. I think the hard part though is the bed. The beds are $80 to $100 used, or not used, but on the clone market. So what in the world is Oscar Mike? So my buddy Noah, he was a 2-time Iraqi veteran, or 2-time Iraqi tour dude. He's a veteran. He just finished his 2nd tour of Iraq, and he was done. He was done with the military. He was coming back home. Got to California. Him and his buddy decided to drive it instead of sleep. The driver fell asleep. His car went over a cliff, and his buddy died. Noah ended up paralyzed from the chest down. Noah then started an organization called Oscar Mike, which is a 100% veteran run and owned, and 100% veteran, 100% non-for-profit, that all of their proceeds goes to vets that are injured. And he runs clinics and things to teach people to do things. He runs wheelchair rugby tournaments and different skiing events and all the stuff. He has a compound. So Oscar Mike is basically this idea that, which in the military, Oscar Mike means on the move. So I work with them a ton. They're actually who I worked with all weekend. And I just did a big shoot for them. So I have a ton of their shirts. So you might be seeing me wear a ton of their shirts for the next forever and ever. Let's turn this thing on. I didn't plug the motors in. So let me turn that thing back off. Whew. Pete, that is correct. And that's why I work a lot with them. I'm not a veteran myself, but I respect anyone who wants to fight for the country. And their big thing is getting people to do things, you know, that they're not just stuck in a wheelchair doing nothing. So, and if you've never seen wheelchair rugby, that shit's intense. They play like there's that who cares if they get hurt again. I mean, it's pretty amazing. But the organization is really amazing. They're one of the few that so this is the one thing that's really cool about their company. So they don't just buy shirts from China and slap a logo on it. They built a factory in California that takes American cotton to process it to American cloth, who make their own t-shirts and screen print themselves. So it's bigger than just, and again, they give these jobs to vets and stuff. So yeah, it's a pretty awesome place. It's very inspirational. So it's kind of fun working with them. So, but they the one thing they don't have is a veteran photographer. So I'm the non-vet person that hangs out with them all the time, which is fine. I have my cool nickname and I hang out with them all the time. So now we have the Z-axis steppers plugged in. It boots. I have to hide some of these. I need to do some cable management down here. It's going to take a second to boot because it's got to boot over to the Repetier server. Michael, the best ones you're going to find for Simplify 3D are actually going to be on filamentfrenzy.com. I believe that's Tom Jackson's. Let me unplug the Repetier server. Just let that load. Go to Tom Jackson's website, and that guy's got the best Simplify 3D profiles in the world. Definitely got to have the one civilian there, and that's usually me. All right, it's not booting. Nope, there it is. It's skipping. So we're gonna have to oh yeah. So we need to drop the micro stepping. That is not a good sound. I'm gonna try. Let me go look at the firmware real quick. I'm gonna look at the source code here, and Prusa config, and what is? Let me stare at this for a second. So 3200 divided by 8, which is 400. Okay, and then Z-axis is 1/16. So I'm going to do 1/4. I'm going to do 1/4. So let's set that to 4. And interpolation, it'll stay on. I guess just show you what I'm doing here. Let me go back. Who has the best? I have no idea for slicer. I have some decent ones. Let's see here. Screen share. Okay. So, by the way, if you haven't seen the Alpha 5 is out and they debugged a lot. It's faster. My one help was telling them to have a maximum zoom in limit and no more zoom issues. So that was my fun thing. All right. So this is the I'm in Arduino here. No, I am not going to show. I can hide that. It's fine. So this is the firmware, and this is the section. So it's in the configuration _ Prusa.h. And here's the micro stepping. So I have 1/16 micro stepping for my E-axis. Stock Prusa is 32, but I'm running the BMG09. I'm going to drop Z steps to 4. That way I have the same resolution as before. Not same resolution, but same output. That should be fantastic. It'll sound less insanity. But yeah, you just need to change this line. So normally it would say 16. I changed it to 4. And this thing, for me, went from 32 to 16 because of the stepper I have on there. And let's double check to make sure that compiles. Well, that's doing that thing. I'm going to plug it back into Repetier server so I can do a firmware update. Yeah. It's not optimized. Archiving, build core caching. Yeah, it's fine. So that passed. We'll run the verify again. It's just telling me that there's a cache that it's making. So we'll do it again. Make sure that error clears from the new cache. Yep, error cleared. So we're going to go to Sketch and export compiled binary. And so it's going to recompile and then save the fancy thing. All right, we're logged into Repetier server. So let's hop over here to Repetier server, and we're going to go to the Firmware Updater. And we're going to upload a firmware. And so it's going to be in Documents, 3D Printing, Firmware, this firmware here, and firmware.ino.rambo today at 3:03 p.m. Choose. And we're going to update our firmware directly from Repetier server. And yeah, this web page is using significant memory. Thank you. Yep, upgrading firmware. It says do not disconnect. I'll go back to you guys. Stop screen sharing. All right. Yes, the micro steps will be 400 now that we went to 1/4. So, and I'll do that with an M92. Didn't want to save that in the firmware. No notification. Yeah, welcome to YouTube. The link should be filamentfrenzy.com. I think. Should be. Yeah, and the Z step should be back to 400. We definitely don't need 1600 Z steps. Yeah, 1600 Z steps is definitely something ridiculous. And it's loading up again. And we are loaded. And good, we're back into Repetier. So let me screen share again. So screen share. All right, so upload is finished. We'll go back to the console. We'll turn commands back on, and we'll do an M503. And yep, 1600. So we're going to do an M92 Z400. Boom. And an M500. I have an M43. M92 Z400. Okay, that's just what it does. Okay. So M500 and M503 to double check. Yes, Z is back to 400 microsteps. And we can go back to not screen sharing. See if this thing moves correctly. Oh, we got binding. So what I need to do is, ooh, we got some binding on Nexus. I'm going to, should I up the motor current? Let me make sure that the Z-axis is level before I go any further. Because one of the issues with this is there could be more binding. Someone did mention it. And it might be that, but what I think it is my Z-axis, the palm nuts. No, the originals are T8 by 8. Okay. turn this bad boy off. Of course, I can't run it down manually. Because one of the things that can happen, which I think is happening right now, is the palm nuts. So there's some little bit of give in the Prusa palm nuts. So you can actually move them left and right and around and stuff. So I'm going to loosen them up and try to realign it so the Z-axis threaded rods are level. I just need to get them low enough to do so. And that should do it. All right. Let's try that again. Nope. Unplug the repeater so it'll load faster. Yeah, there's no SL1 outside of Prusa at the moment. They kind of made that. Nicholas mentioned that in the Prusa Facebook group because someone asked. So, all right. Let's move the Z. It's definitely still skipping. So I'm going to change the feed rate, which I think is too fast. Yeah, feed rate is definitely too fast. Other than that, I think this will work. Let me try something real quick. Calibration and auto home. Yep. So it's the combination of the trinamic drivers, and there's Prusa has a has the what's that thing called? The magic thing. There's a magic thing that they use to make sure it doesn't have the crash detection kicks in, and then it skips. Now the current on the Z-axis is actually very low. Let's take a look here. What's the current on the Z-axis? Z-axis current. The feed rate for the Z isn't that bad. The max acceleration isn't bad for the Z. But where's that current? Current. Feed rate, position, current. Current. You're somewhere here. Nope. Nope. Temperature sensor. Nope. Gone too far. So I'm going to try to find the current. See what it has set up. Homing feed rate on the Z is... Okay. Yeah, they got stall guard homing for the Z. So I need to fix that. And where's my current? All right. Should be right underneath here. Ah, there it is. Holding current on the Z is 16. So I have no idea what the math is on that. I'm going to up it a bit. So we're going to go back to stall guard. Yeah, so there's Prusa has built-in protection, so if it hits something or has too much force and it breaks the amount of current needed to move it, it stops the axis and kicks in stall guard and tries to do the stuff. TMC status output was removed in 3.5.0. I don't know when they're going to re-enable that, so I have to look at the firmware. But I can use M907. Let's see. And whoop, sorry about that, everybody. Bumped my microphone. Try to get back into Repetitor server. That's also angry at me right now. Dun dun dun. And there we go. That's a better sound. Okay. So you need to send an M907. Is it 907? Yeah, it's 907. So commands on M907 Z, and we'll set the current to 500. 100. Nope, stall guard still is kicking in. So I have to mess with firmware to make this work, which is unfortunate. I might also have to mess with feed rate because it might just be too fast for the TR2s. I'll probably talk to the guys at the Railcore team to see what they're doing. But yeah, it's definitely stalling out. Just a little bit. Just a little bit of stall out there. I might have to mess with feed rates and other fancy things to make this thing a functional thing. The only thing else I can try is turning off the interpolation, the 256 microstep interpolation, so that way it's not also an issue. Let's see here. Dun, 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 dun. The filament that I printed in is Fibrology Vertigo PETG. Yeah, it's either the stall or the bind, and it could be both. It could be stalling because it's binding. So let me do one more firmware try here. I'm going to manually set the Z-stepper current. And you know what, let me check one other thing here. Let me send M503 real quick. And yep, that's fine. So M203, let's change the feed rate on the Z-axis. So M203, Z100, M500 to save that, M503 double check. I'm going to lower the max feed rate. And okay, that's a little bit better. So M203, Z60, M500, M503 to double check. That is correct. Okay. Let's change the Z acceleration maximum down. So that's going to be M201, M201Z, and we'll change that to 100 acceleration. M500, M503 to double check. So acceleration is dropped to 100. And let's lower the Oh, the Z jerk is low enough. And let's see what we got now. Yep, it doesn't like that. It doesn't like that at all. 16 is 200 milliamperes. See, set it to 25. That's not a bad idea. So I'm actually just going to do this in 8. So it is 2. And let me look at this firmware real quick one more time. I'll let you guys join in on the firmware looking. Firmware looking and share. So I am changing the default axis steps per unit from 3200 divided by 8 to divided by 2. And we are going to look through here real quick. Homing feed rate. The z-axis for homing will be 60. And default max feed rate, XY. Yep. And acceleration for the Z will be 50. And I guess I should divide these by 4. Let's just do that. So, yeah, that's 50. Look at me being smarter than I actually am. Acceleration. Maximum manual feed rate. And z-axis will not be 1,000. That'll be 200. And crash detection. Nope. No. Fan check. Nope. And we'll turn off interpolation on the z-axis. We'll turn off interpolation, so there's no 256 microstepping. And here's my motor current, holding and running current. So 16. It's weird that they flip it too. So this is Z, X, Y, E, which is always odd. At least I think it is. Yeah, 16 is what it's set for. So we'll go to 30. Go to 30, which should be 500 milliamperes about. I think that's all I need to change on this firmware. That should do it. And it's funny that the micro stepping for the Z is 0.1 millimeters when it can't actually move at 0.1 millimeters without micro stepping. There's no speed there. I think I have all the speeds turned way down. Okay, so we'll double check our thingy, our verification. Yeah. Compiling the sketch. Shouldn't have any errors because we already have our new boot thingy. And sketch, export compiled binary, and stop screen sharing. Okay. Yeah, custom Mendel name. Well, welcome to Prusa technology. All right. Let me go take a look here. And loading back into Repetier server. And I can do the firmware update again. So firmware updater. and upload firmware image. And yep, 3:21 p.m. New firmware installing. Yeah, thank you, Crystal. By the way, Crystal is the guy who did the 7x7 firmware. That dude's a beast mode. And that's the firmware fork I'm using for this right now. I'm using Crystal's 7x7 firmware and messing around with everything. 139 people are going to see whether I can make this work or not, the old-fashioned way. So it looks like my downfalls are going to be having to run at much slower speeds. And this should slow it way down. Like way down. Because I think I lowered everything. If they're not in the config Prusa, I don't know where to change those. It's hammer and crowbar. Yeah, that firmware is on GitHub. Go to the Prusa GitHub, go to their firmware section, click on the forks at the top, and look for one by Stahl Fabric. Okay, we have the new firmware installed. We'll see if the Z-axis is any better. Oh, wait, I got to do one thing. I got to make sure the steps are correct. So console M503. And yes, the Z-axis is still correct in the number of steps. So, all right, it's not stalling. Okay, and we'll go to settings. No, not settings. We'll go to calibration, and we're gonna go to auto home. I don't understand why auto home is in calibration. Bruce, can we move that to like something that makes sense? Like, why can't auto home just be in the main menu? Because it's not a calibration tool. Oh, that feed rate's slow. All right. I might have set the value a little too low, but it's working. It is moving, by the way. I'll turn this towards everyone so they can watch it. So it is lowering down. Hey, but it's not snagging. So this is good. I can go up from here. So yeah, we've definitely hit turtle speed on the Z-axis. I'm taking a wild guess I can go much faster. Oh, man. Yep. But you know what the good news is? This means that it will work. It just means that I need to tune the feed rates. I'm guessing I need to leave the microstepping off, the interpolation turned off, because with that 256 microstepping, we're losing a lot of torque. 30% of your torque is lost to that 256 microstepping. The 1/4 with the additional amounts of awesomeness. Yeah, but this is good. We need to have some of that gravity. Yeah, this is the full bear, Francesco. Oh, man. So you can tell why Chris Riley takes so long to build his projects while we're on the Sunday. Was it fun in the country basement? Because he probably doesn't want to do this on live camera when he's like, oh, man, I probably shouldn't have set the feed rate to 5. That is the smoothest Z-axis ever. That's what we just built. Smooth. Super smooth. Oh, my gosh. Yeah, there's definitely some Swedish technology on this thing, and also some really bad technology on my part. It started here, started at the very top. Now it's working its way down. The good news is we figured out that it is the will the bear frame cope with the speed? No, I think it's gonna explode. It definitely didn't stop. But yeah, I definitely need to increase some of the feed rates there. Let me go ahead and go back here and look at these feed rates that I changed. So this is the homing feed rate. And I'm guessing I changed it too much. Oh boy. Oh boy. So homing feed rate. I don't even know where that is anymore. I found it somehow while going through this nonsense. Let me go through here again. So on the top. Oh, wait. It's homed. I went to 60. Let's go from 60 to 120. I bet you it's 3,000 millimeters per centimeters per second. So let me try 300, and we'll recompile this. Hit the verify button. So now that we're here, okay, yeah. So we're not binding. It was definitely one of the feed rates was just too much of a feed rate for it. And I don't mind that it takes this long to move the z-axis up. I have nothing better to do. So now we need to see if it'll print anything. But I also need to redo the first layer calibration and a couple other things. But let me get this homing feed rate set properly. So let me sketch. Let me export the compiled binary and see if this fixes the homing feed rate. This is such a cute... Oh, go back to the comments here. I feel like I'm going to get punished here. All right, 7 years later. The stock Z current is 35. What current did I turn up that was 16? Which current was 16? Yeah, this is the Mark IV. As you can see, they fixed everything you wanted in the Z-axis movement. It is smooth. It's so smooth in the Z-axis. I mean, there's nothing. 60 is for the big boys. Yeah, Mark IVs are all bare frames, and they run at really slow Z-axis speeds. Oh. Okay. It homes. All right. Let me put a new firmware in there. File, firmware upload firmware image, and choose and see if that's gonna be better. I'm definitely joking. It's been a long day for me, and the fact that I just installed these things and I'm just making stuff up as I go to make it work. I mean, I'm editing firmware to make this thing work. This is already telling me this is going to be a fun project. No, there's no Mark IV on the sales page. There'll be a Mark IIIs before there'll be a Mark IV. Yeah, smooth, fast, and quiet. Pick two. You can't have all three. This is very true. You could do a firmware tweak to make it faster, and I think they have done that. So, but this should make the homing faster. I just upped it from 60 to 200 to 300 or something. I have no idea what I changed it to. I changed it to something. Whatever I change it to, it's going to be faster than it was before for homing. So, I think 5 times faster, which I think is still good enough. All right. It's booting back up. It is connected to the repair server. Let's go to the calibration menu. Oop. Calibration menu. There you go. Calibration and auto home. Let's see if this is better. I mean, that's a better speed. That's a way better speed, right? All right. Oh my gosh. Oh. Okay. I just need to level the. So let me go to. Oh god. Let's see if it doesn't break now. Calibration and calibrate Z. Okay. That's fine. This is a way better speed. Oh. It stalled out. No, no, you silly banana peel. Oh boy. There's other things to fix. Let me raise this all the way at the top. Yes, the PSU is not rattling. Yeah, this is. I still need to make sure that it hits the bar and the gantry is level. Because I'm guessing if the gantry isn't level, this thing's gonna be mad at me. Yeah, there's definitely a little bit of it. James, I think I have one in the Prusa community Facebook group. Of why I use it. The only reason that I really use it more than I use Octoprint anymore is just I can host more printers easily, and it's just easier to set up, and it does things that I like. For most people, Octoprint's perfect. I think that 95% of everyone should be using Octoprint. It just solves an issue that I had with Octoprint. Okay. So let's calibrate the Z here. Calibration, calibrate Z. There we go. That's a good sound. Okay. It works. I blame everybody on YouTube that makes you buy things. I definitely wouldn't do this. This seems like a much more of a pet project than something that's I might try T by 4s. Oh gosh. That is boom, 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 boom. So luckily I'm not doing 7x7 mesh bed leveling right now, because that might take a while. And yes, this is Capricorn tube. I have bucket loads of PTFE tubing from Capricorn, from Floor Store, from everything. And yeah, so I just grabbed it and put it on because already the length that I needed. This is about the length that I use for the reverse Bowden. What's up, Joe? It's alive. It's just really slow because the oh, not having the trinamic drivers turned on the Z is just fun. Okay. Let's put some filament in there and see if we can print something. I mean, it looks like it's moving great. I think we have all the settings correct. Let's warm this bad. Ooh, let's preheat to PLA. What filament do I want? What do I have that's neat? I got some white filament. I should definitely put some googly eyes just general on the printer because the way how slow it moves. Let me grab some filament. So, why did I change them? Because I'm insane. No, this is Atomic, their special blend of bright white PLA that prints actually really, really well for a white filament. Yeah. All right, let's load this film. Actually, let me raise the Z-axis up a little bit. And up it goes, really slow. Okay, let's load some filament. Load filament. All right, that works. So, yeah, I'm going to move it. Let me do that. Filament is loaded. Yes. Oh, what did you miss? Really slow Z-axis movement. So, nothing in particular that was missed. We won't even talk about it. I'm just going to ignore the fact that I had to custom make firmware in front of everybody to make this thing work. All right, that should show you what's going on. I do have that pretty black screen, the black on white screen. So this has all my mods on it. Gantry is level. We've loaded filament. We are at temp, which I don't want to be at temp. So let me go back to the bare. Turn the temp off. So turn that off. Turn the bed off. And let's go slice something. Let's go slice something to print. Let's switch to screen share again. Screen share. Okay, so we're in the Alpha 5, which is awesome. They fixed some of the issues that were going on in Alpha 3 and 4. So I have a bunch of files here. I will print. So that's going to be documents, 3D printing, test prints. We'll do a cute octo. We'll print them tiny. So files, cute octo, pop them in there. And we need to rotate this. So this is the rotate button. Whee! There's our cute octo. We have our BMG profile. Let's make him tiny. So tiny cute octo. So scale factor, is that locked? That's unlocked. So this is locked. So scale factor of 20%. We'll see if we can print a 20% cute octo. Maybe not that small. Let's do a 40% cute octo. And we will change some print settings here. First layer height we'll say at 0.2. The second one we will do 0.5. And 2 perimeters to make this go faster. I don't care about top and bottom layers. And infill, we'll leave it there. Skirt and brim, leave it there. We don't need any support material. Speeds, I will leave them. Why not? Anything advanced? No. Filament settings, no, don't need to do anything here. But I do need to go here. I need to change some things here. So in the general, nope, custom extruder 1. We need to change our retraction length to 0.4. We don't need to retract as much when we're printing at a lower layer height. And our lift Z, we will make that 0.1. Yes, 0.1 millimeters. Traction speed, blah, blah, blah. That'll stay the same. And custom G code, we will turn off. Let me scroll back up. We're going to turn off the 7x7 because that's going to take forever. So we're just going to go to G80 and we'll turn this line off. Just delete that for now. And there we go. So we're going to slice with that. So slice now. And yep, there we go. We have a really fine looking dude here. Export G code. And we'll make him a tiny cute octo. Tiny. Boom. Over to Repetier, and we're going to upload a test print. So documents, 3D printing, and to print, and our BMG PLA tiny cute octo. Let that render. This is one of the things I do really like about these nice rendered images of everything that you're going to print. So if I go to my fancy superheroes prints I've been printing, you can see all the cool things I printed. And it even shows you where the supports are, and you can you can actually edit the G code here if you want to. So you can edit that. You can see a 2D preview, 3D preview. You can see all the layer numbers and all the magic, what slicer was used. It's pretty neat. So let's go back to test prints. And there's our tiny cute octo. Let's hit print and print. And let's see if we don't cause any issues. Okay. Did I break YouTube? The stream access is not really slow. Alt F4. I don't want to do Alt F4. So yeah, we're gonna do our first print at really small layer height. I mean, it's a regular layer height. I'll try smaller later, but 0.05 is a good starting point. Oh man, 32 viewers left. Did something happen? Did we lose everybody? It still says I'm live. Am I still there? Hello? Dun dun dun. No. Oh, son of a gun. All right. Let's Thingiverse. All right, is that better? Am I live again? Am I live again? Playback ID error. No. Whoa.